Well, today, Saturday, I'm not supposed to do CB repairs on a Saturday. We've got such a backlog. So this is from Mike. He sent stuff in before. He's bought this off eBay. And it's sold as parts not working. Good conditioner is light cosmetic wear to the sides and top of the transceiver. The front of the unit and the handset are like new. Something has had the end snipped off, but these don't seem to be hard to source. The manual's in very good condition. The box is in reasonable condition. Untested, I know nothing of the history of it. It's being sold for spares and repairs. Let's see. So it doesn't power up, he says in his letter. May have been opened up. I want to check for something obvious. There's no obvious work from a screwdriver expert. It looks neat and tidy and it smells like new. Good. This is box number 10. For those of you with repairs in, we're on box number 10. And it's the only radio in that box. Sometimes you've got 7 radios in a box, and we are only supposed to be doing 1 CB per week. Now, we'll probably end up scanning that because it may be better than the photocopy I would have done at the time. Would get the colour cover. So we've got the factory original mic. So it's come with the power lead. This is probably a new one because I think they were harping on about the end being cut off, and this certainly isn't, so we'll use that. Very nice. And you know, Knights of Curtin and Lindsay, they offer an aerosol paint spray, which is, they call it Rotel Gunmetal Grey. So I think I tried one and I don't think I got on with it, but that might be my preparation, which was poor. Right, I shouldn't need to put the soldering iron on because it's, I mean, yes, I'll need to put the soldering iron on because there'll be wax in the cores, won't there? Now, unlike the Falcon we did yesterday and the Maxcom we didn't finish the day before, hopefully this will be a straightforward service, and the reason that it's got no lighting up hopefully will be very, very straightforward. So it's a 1981 set, we're now in 2022, so it's 41 years old, you know. A lot of these sets have stood the test of time. A lot haven't. There are some that haven't, and of course the Shogun's one of them. A swish and disappointing. So, using his power lead, just going to check we've got the right fuse in there. I'm going to have to take any frequency measurements with a pinch of salt because I've only just put the test equipment on. So at the moment we've got the 10 decibel attenuator switched on, so we'll switch that off. So that might help it transmit when we get to that. I don't actually have any inherent capacitor problems with the Cybernet 134 chassis. This is the Rotel 220. It has a receive circuit less than the 230. The 230 has the same circuit as the 240, and those SMC Oscar 1s that always work very well have the same circuit as the 230. So some of the lesser knob sets like the York 861, the Binatone Speedway, have got the lesser receive circuit. But some of the 2 knob ones, like the Oscar 1, have got the better receive circuit. So Cybernet 134s aren't quite all the same. 2 amp, that's excellent. So it's never going to draw more than 1.6 even on a bad day. Unlike new sets. This is weird. I can see a shorting link where the protection diode should be. Well, that will stop it working, wouldn't it? And it looks beautifully done. Whoops. So I'm going to connect it to my power supply. The power supply is going to be set to 9 volts and current limited to 350 milliamps. And we've actually got no anomalies. So we'll get the little multimeter out, seeing as the Aldi one's in the chapel where we're working on the organ, not because we need it for the organ, but because we were doing one of those stereo masters in there and it's not managed to come back. So I do prefer that one, but I'm sure this 12.99 meter is more than adequate. So let's just check we've got power coming in. And the answer is no. So let's check the actual. We've got nothing coming out of the power lead. So let's see what's gone wrong. I'll plug that back in because it'll be easier to do the tests. So what can happen, the fuse holder could not have been crimped properly. So here's a little test. Assuming we've got a negative chassis, so I've put the negative to chassis, let's put that to my crocodile clip. May not be the right thing to do. There's our 9 volts, which I said our power supply is doing. So it isn't a floating, it's a floating chassis, isn't it? So we need to really borrow one of Mr Chippie's crocodile clip leads, but I think he's had them all back. This is the input side, and we've got our 9 volts. So have we got a fuse that's duff? Yeah, we've got a fuse that's duff. We've probably got a fuse that's duff because the protection diode's been linked out. Very, very quickly I'm going to short the two together, and we went into current limiting. Tell you what, we'll use the SMC Oscar 1 because it's handy. So we can actually find where the power comes in on this. No, the protection diode is diode 10. Diode 10. So we've got the power positive going in there, and it's diode 10. So if I can find diode 10, see if I can find it on the layout first. There's 9. And there's 10. Right at the edge of the board. And I can see it. Right, we'll park the camera back where it should be and we'll check for continuity. You know what, that's not. That's not showing a short circuit. So what is short circuit? Is the socket wired back to front? Has this ever worked when it was new? So we've got the positive to that side. No. There's the positive. It's plugged in. And look, inside the radio, the negative is on that side and the positive is on that side. Let's look at a scrap chassis. Very similar set. It's the same way around, folks. You know what? This power lead's the wrong way around. So on my set, negative to the left, positive to the right. On that set, negative to the left, positive to the right. We have a little bit of a stub of a Cybernet power lead on here. Here it is. So if I plug that in, our red wire is to the right and our red wire is to the right. Let's pop that back under the bench. So this power lead is factory wired the wrong way round. Let's get a new one out of stock. So this is the normal Cybernet type power lead which we carry in stock. So let's pull out the connector. And like our little stubby one, the red is to the right. So when we plug it into the radio, the red is to the right. So I'll send that back so we can, I'll chuck it on the floor, there we go. I will send it back so we can recover the wire off it if he so wants to. Now I didn't cotton on to that instantly. I thought it was going to be something more complex. Right, well, now we'll connect it up. And we're lit up, channel 2, stick it on 20, switch the power supply to normal 13.8 volts, current limited to 1.6 amps. There we go. So it's not that I'm a clever boy at all. I've taken exams sometimes for things, and like something you've worked in an industry for donkey's years, rather than you've been coached for an exam. If you went to school and you did your O levels, you went to sixth form college and you did your A levels, and so on. You're kind of being coached, aren't you, for the exam? But you know what? If you've worked in something for 20 years and then take an exam in that subject, you can know too much, and you can start looking for things that aren't there. And I think I did a bit of that with the radio ham test. Mind you, that was still a long time ago. Was it 79? Could have been. Right, we'll plug the test equipment now into the receptacle provided. Now, if I'd have tested this radio on the little stub lead, which I normally do, volume control wants a bit of spray. We wouldn't normally get the power lead coming in. I'd just normally test it on there. I put the crocodile clips on. That would have gone back to customer. He'd have blown his fuse, and he'd think, "Well, they haven't fixed it. How come it was working?" So I'm glad he sent the power lead in. Right, I'll get a piece of paper, and then we can write down what parameters this radio is doing right now. I wonder what silly piece of second-hand paper I can find today. I think we're done with that. Church services for July 22nd. Rotel 220. Right, we'll select picture in picture. So if it's never been touched, it'll be doing wrong side. If it's never been touched, it'll be doing about 3.4 watts and about 1.6 deviation. Well, in fact, it's not transmitting at all. How can that be? I'll tell you how that can be. Because we're plugged into the aerial and not the test equipment. There's me out keying out channel 20 in the middle of nowhere. It's going to upset all the birds. Right, try again. Hey! 3 watts exactly. Frequency. This test set is warmed up sufficiently to take a reading. 27799.087. It's just in spec. No, it's more than just in spec, it's usable. But we'd like to bring that up. You know what, I'm going to do that right now. So we'll just find the crystal trimmer, which is the red one there. There we are, 25 toggling 26. So that's that done. Deviation. Wallow. Better go back to the other meter. Wallow. Wallow. 1.5 kilohertz. I wonder if that was the power lead. Anyway, he'll tell me. Let's look at receive. So we'll just dial in the required frequency into the signal generator. So it's 2779125. switch the cyanide meter on. And let's get a reading. So we're in the 1 and we're on the 4.3. So it's 0.43 microvolts for 12 dB, which is already fine. Right, let's get on with it. So we'll do the VCO. I'll still need the notes because it must be all of 4 days since I did a Cybernet 134. Select channel 40. So we have to put our earth onto a can, not the chassis. And we're looking for 4 volts on receive. At that test point 4. And look at that, it's 4 volts on receive. Going to transmit. It should be 4 volts, it's 3.9. I'm not touching that because it's within 0.1. And then we go to channel 1. And it's supposed to be between, is it 1.8 and 1.9 and 2.5, which it isn't in transmit. It's supposed to be between 1.8 and 2.5, which it is. So the VCO is spot on, we're not touching it. Bob's your uncle. To get those voltages, we've said a million times before, it's the coil there for receive and it's the trimmer there for transmit. No reason to touch those. But had I not checked, it would have been miles out, because that's how it works. So hopefully we can get some power out of this. So let's put that back to there. So we're at exactly 3 watts at the moment. And I'm foolishly not on channel 20. So far they're spot on. And then we need to maximise the 3 here initially. So at the moment that's 4.4, 4.5, 4.6, just check. Need to do this quickly, I don't want to damage the transmitter stage. It's not going to like being on full whack for many seconds. On the Pi M201 VHF high band AM radio telephones, which we did a lot of when I was at Nottingham Radio, you actually, when you were on transmit at maximum power, smoke came out of the radio. You really needed to keep it under about 10 seconds. They had a 60 watt PA in order to do about 7 watts. That's how on top of the job they were. So 4, 8 and 9. So now we're going to rotate 4 clockwise to get 4.4 watts. So there we are, 4.6. So we're going clockwise, 4.5, 4.4. And then with the green one, which is L9, if I remember rightly, yeah, we go anti-clockwise, and the manual says for 3.8 watts, but they're entitled to 4 watts. We're not just trying to get through a radio through customs, so they're going to get everything they're entitled to, which is the full 4 watts. So now we need to check the balance. It needs to be really between 0.1 of a watt between channel 1 and 40. Channel 1, 4.02 I would estimate. Channel 1, 4 dead. So yeah, that's nicely balanced. Good. Sometimes these sets will only just do 4 watts, and it's difficult to balance because they'll only do 4 watts. Sometimes you get one that does 5.5 watts, and so it will balance beautifully when it gets to 4 watts. And this is 4.6, and so it will balance nicely. But there's manufacturing tolerance, of course, between components. If you have 5 cars the same, they're not all going to do the same miles per gallon, not all going to do the same acceleration. So, let's look at the power meter. So, remember these are relative power meters. When you put it on an aerial, it actually means diddly squat. But on a dummy load, which is built into the test set here, it's meaningful. It's just under the 4, so we'll just change that so that it's on the 4. See, that was a lazy meter, wasn't it? For a set that's supposed to be new. Let's check low power. There's a little slide switch at the back. So we want 400 milliwatts. So I'm now in the 3 watt range, so we should be reading just there. We're not, we're reading 110 milliwatts. So let's just pop that up. About 410 milliwatts, so that's there. Back to normal, 4 watts. Deviation, I need to set the automatic gain control-y thing to midpoint. I find that's the best position. There's a really long and drawn out way of setting this up, injecting signals here and there and everywhere. But this is where experience comes in. That's in the halfway position, and then we'll use the deviation control there. So let's see what it is now. Wallow, it's 1.5 just as it was. So we'll pop that up, putting the oscillator on. Probably about there. Wallow, not quite, give them a fraction more. Wallow, that's it. So we've now got 4 watts. We've got 2.2 to 2.5 kilohertz deviation. It's what the wallow is about, that peak. It gives me that peak. So it's a good test which Pi taught me when I was doing some training at Pi, which then became Philips, which then became Simoco. What was it? Systems Integrated Management something company. I understand it was a pension fund for Australian teachers or something. How bizarre. Anyway, stopped dealing with them after that. So we're done. We're done on transmit. So it's quite possible that nothing needs doing on receive apart from cleaning that volume control. So we'll start by putting the oscilloscope on. Turn the bench light off, put S9 equivalent signal in of 100 microvolts. Unless you're a radio ham, then it's 56 microvolt. It's 56 microvolts for S9. Something like that. You see how bothered I look? The detector needs to be maximum recovered audio. I'll tell you what, that was out. They can slip in transit. Over to the cyanide meter, which doesn't seem to be centralised anymore. I'll say it's propped up on the Fidelity 1000, that camera. fidelity 1000's probably trying to escape. So we want 4 dB on that meter so the receiver isn't saturated. We'll start with the front end of the receiver. Wow, you know what? I wasn't expecting that. You're not telling me it left the factory like that? Right, next one. Some radios have got one further back, like the Harrier base station. Just put a bit more on. It's a difficult one to see, that. No, it needs to be higher. There isn't one under the wiring today either. Right. Well, why was that so far out? Let's look for a new reading then for a cyanide. Well, we're actually between scales. We're often between scales. So on the lower scale, I've got 0.34 microvolts. And on the higher scale, I've got 0.29. So we'll go between the two and we'll say it's 0.31 microvolts, which is our final figure. So that's excellent. I'm surprised I was able to bring that down. Right, so we're going to put an S9 signal on it again, so 100 microvolts. We'll see where that meter is. It's not quite on the S9. It's 8.5. So we'll just adjust that. There we go. And that now just leaves the squelch. So we're going to turn the squelch to full on the radio. And what I'm wanting is for the squelch to open when I reach 100 microvolts of signal on here. So 0.3, 1, 3, 10, 30, 100. And it's come in spot on. So we don't need to adjust the squelch, it's absolutely spot on. It's the preset just there hiding under the wiring, that preset. I don't know why the tie wrap's missing there either, but it is. Not, it doesn't matter at all. I don't need to put one in. On the other hand, we got that cable tie, didn't we, that came with the power lead. So, sensitivity of squelch. So we've turned the squelch right down. We're going to take the signal generator to 0.3 of a microvolt, and we're going to switch the signal generator to standby. Set the squelch on the radio to threshold. Switch the signal generator back on and see when it comes in. So let's see. So it's opening at 0.45 microvolts. It's closing again at 0.38. So not the best squelch in the world, but an adequate squelch on these sets. That's nice and sensitive, and it'll get round scratchy corner a treat. There we are, we're done. So it wanted a bit of a service, which it's now got, and it's now doing everything he's entitled to. Let's hope the internal speaker works. about 10 o'clock in the morning. I wonder if there's any good buddies out of bed. Yes, it's working on its internal speaker. So I'll disconnect it from the test set. We'll switch off the test set, the soldering iron, all the test gear, and pop the lids on and pause the video. Right, let's see what people we've got out there, because we haven't normally got anybody, have we? Apart from the odd farmer swearing on channel 9 and the odd bucket mouth on channel 19. One Anna Roger. Illegal SSB activity, and I say that because the UK channels are unique to the UK, and SSB on CB isn't authorised up here. Although I'm not naive to know that it doesn't happen. I'll tell you what I've forgotten to do. I've forgotten to spray that volume control because it's dirty. But as far as the video is concerned, that's finished. I'll say thank you for watching. We'll do an on-the-air test later.